All right, so here we are ready to go over rational zeros of polynomial functions. So we're going to put some of that synthetic division knowledge to good use now. So what we're going to do is we are going to work on being able to find the remaining zeros if somebody gives us one of the zeros, right? Or using the rational zero test to find possible zeros, right? If one isn't given to us, this helps us find a starting point. And then to be able to use synthetic division to finish out factoring these larger polynomial functions. Okay, all right, so let's just go ahead and look at kind of what we're talking about. First of all, we want to make sure that we understand what it means for something to be a rational zero. Okay, in order for it to be a zero or a rational zero of a function, that means that if we were to plug that number into the function, it would equal 0, right? Or if we were to plug it in using synthetic division, that it would give us a 0 remainder. So in this problem, it says which function has a rational zero of -6. So all we're going to do is plug -6 into each of these functions and see which one equals 0, right? And I'm not going to plug it in the old way where we plug it in and cube it and square it and all that kind of stuff. I'm just going to use synthetic division. Okay, so I'm going to check function A first. So I'm going to put -6 in my little synthetic box and write out all of my coefficients from that part A function, okay, which is 1, 11, 19, and -66. So we're going to go ahead and bring down our 1. 1 times the -6 in our box gives us a -6. 11 and -6 combines to 5. And then 5 times the -6 in my box gives me a -30. 19 and -30 combines to a -11, and -11 times -6 gives me a +66, which combines to a 0, right? So here I got a 0. Yay! That means that -6 is a 0 of this A function. Okay, so I'm going to go ahead and circle A, and then we do the same thing. Okay, we keep on working and we work through B, C, and D, checking them with synthetic division to see if they will give us a 0 remainder. Okay, so let's go ahead and do that. Looking at our B function, again, we put -6 in our little synthetic house. We write out our coefficients. So our coefficients are now 2, 11, 7, and -136. Okay. We bring our first number down, which is a 2. 2 times the -6 gives me a -12. That combines to -1. -1 times the -6 gives me a +6, which gives me 13. 13 times the -6 gives me -78. And I can already tell without even working out what that is that that's not going to work, right? Nope. It's not going to give me a 0. So let's check the C function, okay? We're still going to put -6 in our box because that's what we're checking to see if it's a 0. And our coefficients are now 1, 11, 7, and -76. So 1, 11, 7, -66. I'm going to draw my line, bring my first one down. So I have 1 times the -6 in my box gives me -6, which combines down to 5. 5 times the -6 in my box gives me a -30, which combines down to -23. And -23, times 6 gives me 138. And we can see that -66 and 138 is not going to combine to 0, so that is a nope. Okay, and then we check our last function, our D function. So we put -6 in our synthetic house, and we check these to see if we get a 0 remainder. So now we're using 2, 11, 19, and -126. Okay. So we draw our line, bring our first one down. 2 times the -6 in my box gives me a -12, which combines down to a -1. -1 times the -6 in my box gives me 6, which combines down to 25. 25 times the -6 in my box is -150. Okay, so again, nope, that does not give us a 0. Okay, so the only one that worked here is this first function in option A. Okay, so this is really just checking to see if something is a 0. Now what we're going to do in the rest of this function is we're going to take it a step further. Okay, now that we know that -6 is a zero of this function, we want to figure out what the other zeros are. Okay, so now that we know that 6 works, what we're going to look at now is taking what's left over here, our quotient from synthetic division, and finding the remaining zeros from it. Okay, so let's look at a problem like that. So this example says, let me move this over, maybe. All right, so this example here is just like that. Find the remaining zeros of a polynomial given one actual zero. So they're giving us this function g of x, and they're telling us that g of x is equal to 0 when x is 10. Okay, so basically they're saying x equals 10 is a 0, right? Now, if we know a 0, we also know that that creates a factor, right? Because the reason we get these zeros in these solutions is from solving a factor. So if I were to move this 10 back across the equal sign, that means that as a factor, x minus 10 would be a factor of this polynomial function. Okay, so 2 bits of information just from them giving us a 0, right? All right, so what we're going to do is we're going to take that given 0, that 10, we're going to put it in our synthetic box, and we're going to write out all of our coefficients, and for one, just make sure it is a 0, and then be able to go further with whatever quotient we're left with. Okay, so notice here we're not missing any terms, so we go ahead and write out all of our coefficients, which is a 1, a -11, an 18, and a -80. So we draw our line, bring our first one down. Okay, 1 times the 10 in our box is 10. That combines down to a -1. -1 times the 10 in my box is -10, which leaves me with an 8. 8 times the 10 in my box is 80, and that combines to 0. Yay! Right? Which we already knew that, right? Because that was given. It was given that it was a 0, but we know the factor now. So what I can do is I can actually write this g function in its factored form, right? Because this 0 that we just took off and we're left with a quotient, right? That produced this factor, x minus 10. And then my remaining factor I get from my quotient that's left over here. So remember, this is my remainder, this is my constant, this is my x, and this is my x squared. So I'm left with x squared minus 1x plus 8. Okay. So what this is asking us to do is, they gave us this first 0, so we already know about that factor, but what they want us to do is find the remaining zeros. So we're going to take this quotient that we're left with and solve it for x to see what the remaining zeros are. Okay, so we always want to try factoring, right, because we know how to factor x squared or quadratic equations. So let's go ahead and see if we can do that. For some, we would have a -1. Our product would be 8. And to get 8, we could use 8 times 1, or we could use 4 times 2, right? And if we look at that, neither of those pairings is going to equal a -1, right? So this one is actually not factorable. So if it's not factorable, we're going to go ahead and use the quadratic formula. So to use the quadratic formula, remember that's x is equal to -b. So our b here is a -1. So we're doing the opposite of -1, plus or minus the square root of b squared, so -1 squared, minus 4 times my a, which is 1, times my c, which is 8. Okay. All over 2 times my a, which is 1. And then we just simplify to figure out what our zeros are. So we end up with a +1 plus or minus the square root of 1 minus 32, right? All over 2. So this gives us 1 plus or minus the square root of, oops, that's a -31, all over 2. And then remember, anytime we have a negative under the radical, that's going to come out as an I, right? So we have x is equal to 1 plus or minus I square root of 31 over 2. Now normally I would go ahead and try to reduce this radical. I would factor that number and see if there's anything I can bring out. But 31 is actually prime. So there's no factors of 31 other than 1 and 31. And so I can't go any further here. Okay, so this means that the remaining zeros of this one are going to be 1 plus I square root of 31 over 2 and 1 minus I square root of 31 over 2. Okay. Now, that's not all the zeros, right? Because 10 is also a 0. But if they give you a problem like this in your homework, they don't expect you to enter the 10 as a 0 because they gave that to you. So you just need to enter the additional remaining zeros that you came up with. Okay, so this is sort of our easy case. Our easy case is when they give you a 0. They're like, hey, here's your starting point, here's your 0. And then all you have to do is plug that 0 in with synthetic and figure out what the remaining zeros are that come from this quotient here, okay? Now, unfortunately, they're not always going to do that. Sometimes they'll just give you the function and say, bam, here you go, find the zeros, right? And how do we know what a potential 0 is, right? We could put any number from the entire universe into this function, right? Do we think maybe 1's a 0, maybe 5/7 is a 0, maybe negative 2.791562 is a 0, right? It's a whole lot of numbers to potentially plug in, not knowing if we're going to get a 0 remainder. So we have this shortcut way of creating a short list, right, of potential zeros. Now, when we make this list, it doesn't mean that they're all going to be zeros, but it just creates a short list of numbers that we can plug in to see if we get a 0 versus pulling every possible number in the universe, okay? So let's go ahead and look at this. This little shortcut we call the rational zero theorem, okay? And what it does is it says we can create a short list of numbers by using the factors of the constant term and the factors of the leading coefficient. So we're just going to make a ratio of those factors. So I'm going to show you what that looks like, okay? So here it says find all the potential rational zeros and then use them to determine the actual. So I'm going to show you how this works. So to determine the possible zeros, we're going to use this shortcut. So we do plus or minus the factors of our constant term, right? So here our constant term is -6. All over the factors of our leading coefficient. So our leading coefficient here is a 1. So we're doing all the factors of -6 divided by all the factors of 1. So I need to figure out what are all the things that divide evenly into -6. Well, really, we have a plus or minus here because let's take 2, for example. 2 is a factor of 6, right? 2 goes into 6. 2 also goes into -6, right? -2 goes into 6. -2 goes into -6. So that's why we use this plus or minus. So we don't have to list all the possible and all the possible positive and negative options. We're just going to put plus or minus, and then we'll just list the positive ones, okay? So everything that goes into 6 would be 1, 2, 3, and 6, right? Everything that divides evenly into 1 is just 1, right? So now we're going to create ratios. So I'm going to do 1 over 1, 2 over 1, 3 over 1, and 6 over 1, which in this case, it's super easy, right? Because if I take all these numbers and just divide them all by 1, I just get all these numbers, which means that my potential rational zeros are going to be plus or minus 1, 2, 3, and 6. Okay. So this basically just created for me a short list, right? A short list of numbers that I can use to try to find an actual 0. So I'm not saying that all of these are going to be zeros, but now I have 8 numbers, right? I could plug in 1, I could plug in -1, I could plug in 2, I could plug in -2, and hopefully one of these will give me a 0 remainder. So I'm going to go ahead and just start plugging them in. I'm going to start with +1. It doesn't matter what you start with. I like to start with 1 because sometimes that's an answer, right? And then we list all of our coefficients just like we did on the last problem. We're not missing any terms, so we have a 1, 3, -4, -6. So I go ahead and bring down my first number. So 1 times the 1 in my box is 1. I combine down to get 4. 4 times the 1 in my box is 4, which combines to get me 0. 1 times 0 is 0. which combines to get me -6. So obviously that did not come out to a 0 remainder, so this is not a 0. Okay, so let's try another one. Let's try -1. Okay, if I put -1 in my box, write out my coefficients, 1, 3, -4, -6. I bring down my 1. 1 times the -1 in my box is -1. 3 minus 1 is 2. 2 times the -1 in my box is -2, which combines down to -6. -6 times the -1 in my box is +6. And looky there, that gave me a 0. Yay! So when I get a 0 remainder, what that's telling me is that this number in my synthetic box is one of the zeros of this polynomial function. So this tells me that x equals -1 is a 0, right? And it should also tell me one of the factors of that polynomial function. So if I were to take this 0 and move it back across the equal sign, this gives me the factor x plus 1. Okay. So now I've been able to factor this function just a little bit. Okay, so I'm going to go ahead and rewrite it. F of x is equal to, we just got this factor x plus 1. And what I'm left with when I take that factor off is the quotient from my synthetic division. Remember, this was my remainder, -6 is my constant, 2 is my x term, and 1 is my x squared term. So I'm left with x squared plus 2x minus 6. Okay? So now I want to take this and try to factor it, right? Or if I can't factor it, I'll quadratic formula. So let's go ahead and try to factor it. My sum would be 2. And my product would be -6 if I want to do the sum product. And -6 I can get by 6 and 1 or by 2 and 3, right? And notice for this problem, neither of those pairings will combine to give me a +2. Okay, I'm going to mark that out. So it's not factorable. So I'm going to go ahead and just write, use the quadratic formula. Okay. So to get this one, and I'm not even going to worry about solving this one, right? Because that one we've already solved right there. We solved it when we did our synthetic. So I'm going to use the quadratic formula just to solve this remaining piece. So I have x is equal to -b. My b is 2, so -2 plus or minus the square root of b squared, so 2 squared, minus 4 times my a, which is 1, times my c, which is -6, all over 2 times my a, which is 1. Okay, so this is going to give me, as I simplify, -2 plus or minus the square root of 4 plus 24 all over 2, right? And I keep simplifying, so I get -2 plus or minus the square root of 28 over 2. Now 28 is not a perfect square, but I should be able to reduce that radical a little bit. So 28, if you remember, is the same thing as 4 times 7. And 4 is a perfect square, right? That's 2 times 2, right? So if you think about taking the square root of 4, that's 2. That means I can bring out a 2, right? And I should have a 7 left over underneath my radical. So I end up with x is equal to -2 plus or minus the 2 that I brought out from that 4, and the 7 I have left underneath the radical. And then notice this should be all over 2, but I see since both of these are divisible by 2, instead of writing one big line and putting it all over 2, I'm just going to write the 2 under each piece. That way I can just reduce it. Okay, so I end up with -1 plus or minus the square root of 7. Okay, so now I have all of my actual zeros, right? We started with these potential zeros, but the actual zeros that we ended up with was the -1, right, that we got from doing this synthetic where we got the 0 remainder, -1, and then these two that we got from using the quadratic formula with that quotient, right? So we have -1 plus the square root of 7 and -1 minus the square root of 7. So these are our actual zeros. So notice what this tells me is that if I would have plugged in all of these potential, if I would have plugged in +1, -1, +2, -2, +3, -3, +6, -6, that the only one that would have worked is -1, right? Because the other ones we got were not rational zeros, right? These were irrational. So what my point is, is that we always want to plug in until we get a zero remainder and then take what we have left over to find the remaining ones, okay? Don't just plug in all of these and say kind of like yes or no, this one works, this one doesn't, this one does, this one doesn't, okay? Always just find the first one that works and then get the remaining zeros from your leftover here. Because if you were to just plug in the potentials, you would be missing out on these other ones that aren't rational zeros, okay? All right, let's look at another example. Same idea down here at the bottom. I have to start by finding all of the potential zeros. So to find all of my potential zeros, I do plus or minus the factors of my constant term, which in this case is -15, all over the factors of my leading coefficient, which is 2. So I'm going to go ahead and list out all the factors of 15, which would be 1, 3, 5, and 15, and all the factors of 2, which would just be 1 and 2. Okay, and then I want to make a ratio of all possible numbers. So what I'm going to do is I'm going to take all of these numbers and divide them by 1. Okay, so that gives me 1, 3, 5, and 15. And then I'm going to take all of these numbers and divide them by 2. So that will give me 1/2, 3/2, 5/2, and 15/2. Okay, so these are all the potential rational zeros. So this is going to be my starting list. Okay, so this is my short list that I should be able to start plugging these in and hopefully find one that will give me a zero remainder. Okay, so let's go ahead and start plugging them in. Again, I'm going to start with 1, and I'm not missing any terms, so I want to go ahead and write out my coefficients. So 2, -3, -32, -15. I bring down my first one, which is a 2. 2 times 1 gives me 2, which combines down to -1. -1 times the 1 in my box is -1. That combines to -33. -33 times 1 is -33, which is not going to give me a 0, right? That's not going to work. All right, so I was pretty far away, 15 and 33, that, you know, I didn't even have one positive, one negative. So I'm going to pick, I'm just going to pick a bigger number and see if that works. Let's try 5, okay? Let's try 5. 2, -3, -32, -15. So let's bring down 2. 2 times 5 is 10. -3 and 10 gives me a 7. 7 times 5 is 35, which will leave me with a 3. And then 3 times the 5 in my box gives me a 15, which gives me the 0 I needed. Yay! And there's great rejoicing from all of you. I can feel it. All right, so there's no rhyme or reason. You may have plugged in 1, -1, 3, -3, 5, -5, 15, 1/2, whatever. Okay, you just keep plugging in until you find one that gives you a 0 remainder, all right? So what this tells me is that x equals 5 is a 0, and that x minus 5, right, when I move that 5 back over, gives me a factor. Okay. And then I'm going to write what's left over here. We know 0 is our remainder, which means that 3 is our constant, 7 is our x, and 2 is our x squared. So I'm just going to rewrite what we have here now with this polynomial equation. Okay, we have the factor x minus 5, and then we have this leftover factor that came from our quotient, which is 2x squared plus 7x plus 3 equals 0. Okay. And this is what we need to go ahead and see if we can factor, and if not, we can use quadratic formula, okay? So I'm going to come over here to the side and see if we can do sum product. So our sum is 7, which is our middle coefficient, and our product, remember, is our first coefficient times our last, which is 2 times 3, which gives me a 6. So can I get 7 from factors of 6. And I can, right? I can actually use 6 and 1. But I can't use the shortcut here because my leading coefficient is a 2. So I'm going to go ahead and write no shortcut. So if I can't use the shortcut, that means I'm going to take these two numbers that I found in my chart and replace that middle term so I can do grouping. So I have 2x squared plus 6x plus 1x plus 3 equals 0, right? I'm not going to solve this one because we already solved it there. So I'm just going to worry about this piece, factoring it by grouping. So out of the first pairing, I can take out a 2x, which leaves me with x plus 3. And then what I can take out of these, well, they don't really have anything in common, but I can always take out a positive 1, right? So if I take out a positive 1, I'll be left with x plus 3. And now that they both have an x plus 3, I can take out that quantity, and I'll be left with 2x from the first one and plus 1 from the second one. So 2x plus 1 equals 0. And then I just set each of these equal to 0 so I can solve. So when I solve this one, I'll get x equals negative 3. When I solve this one, I'll get 2x equals negative 1. When I move that 1 over, right? And then I just divide off the 2. So x equals negative 1/2. So this means that the actual zeros that I get from this problem is this first one, 5, right? Because I got the 0, 5 from synthetic. And then with my quotient that was left over by factoring it, I also got negative 3 and negative 1/2. Okay, so far so good? Maybe. Let's look at one more and then I will have y'all try some. Okay. All right. So looking at this one, first thing I do, again, they're not giving me a 0. And if they're not giving me a 0, I have to come up with the potential zeros, right? So I'm going to find the potential zeros first. And I do that by plus or minus the factors of my constant term, which in this case is 36, divided by the factors of my leading coefficient, which here is a 1. Okay. Now, this actually works out nice for us because notice anytime your leading coefficient is a 1, the only factors that you have of 1 is just 1, right? So we're going to take all the factors of 36 and write them over 1. Well, any number over 1 is just itself. So really all we're getting here for our potentials is all the factors of 36. So I'm going to go ahead and just list what all the factors of 36 are. So numbers that go into 36 would be 1, 2, 3, 4, 6, 9, 12, 18, and 36, right? So these are all of our potential zeros. So these are all the numbers, all the rational numbers that we could take and start plugging into synthetic until we find one that works, okay? So let's go ahead and start plugging some in. So let's try 1. I like to start with 1. And then we need to write out all of our coefficients. Notice here, though, we're missing a term, right? We're missing an x term. So we need to go ahead and consider that we have like a 0x here. Okay, so if you're ever missing a term, remember to put in a 0 placeholder. So when we write out our coefficients, we have a 1, a 7, a 0, and a negative 36. Okay, so I bring down my 1. 1 times the 1 in my box is 1, which combines to 8. 8 times the 1 in my box is 8, which combines to 8. 8 times the 1 in my box is 8 again, and negative 36 and 8 is not going to give me a 0 remainder. So 1 doesn't work. So let's try negative 1. Let's try negative 1. 1, 7, 0, negative 36. So if I bring down a 1, 1 times negative 1 is negative 1. 7 minus 1 is 6. 6 times the negative 1 in my box is negative 6, which combines down to negative 6. Negative 6 times the negative 1 in my box is positive 6, and I'm still not getting there. right? So let's see. Notice we're pretty far away, right? So I'm going to use a bigger number. Let's use 3, or let's use -3. Let's try -3. 170, -36. -3 is in my box. I bring down my 1. 1 times -3 gives me -3. 7 minus 3 leaves me with a 4. 4 times the -3 in my box is -12. And when I combine down, that gives me -12. -12 times the -3 in my box gives me +36. Yay, and there it is. Yay, our 0 remainder. Okay. All right, so now that we got something that has a 0 remainder, we need to go ahead and write that. That means that -3 is a 0. And as a factor, right, -3, if I move it back across the equal sign, would be x plus 3 is a factor. Okay. And then what we're left with here on our quotient, 0 is our remainder. So that means -12 is our constant, 4 is my x term, and 1 is my x squared. Okay. So I'm going to go ahead and just rewrite this equation in its factored form now. Okay. So this first factor we got is x plus 3. And the quotient that we were left with down here is x squared plus 4x minus 12. Okay, and again, I'm not going to solve that one because we already got that one from synthetic, but I do need to see if I can solve this one. So I'm going to try to solve it factoring, and then if it doesn't factor, we'll use quadratic formula. Okay, so if I look at my sum, I have a 4. If I look at my product, it's -12. And this one is factorable, right? Because I can use 6 and -2 that multiplied give me -12, and 6 minus 2 combined to give me that +4. And as added bonus here, our leading coefficient is a 1. So that means we can use our shortcut. Yay for shortcuts. Okay, so this one factors into x plus 6 times x minus 2. And then all we have to do is solve each of these factors. So when I solve here, I get -6. When I solve here, I get +2, which means that all of the actual zeros from this entire problem is the -3 here that we got from synthetic, right? And then once we factored our quotient, we got a -6 and a +2. There we go. All right, we kind of okay with the process. Synthetic division is definitely going to be a big part of our life now, right? In this section and the next. So if you haven't done that synthetic division homework, make sure you do that one before you attempt this one. All right, so there are 3 practice problems for you. Number 1 is very similar to the ones that I did. Number 2 is just checking to see if the given numbers are zeros. And then number 3 is they give you one of the zeros and you just have to find the remaining ones. Okay, so go ahead and pause the video, and whenever you're ready to check yourself, or if you get stuck, go ahead and unpause it and we'll go through them. Okay. All right, so looking at this first practice problem, we find our potential factors by finding the factors of our constant term over the factors of our leading coefficient. So all the factors of 3, which would be 1 and 3, divided by the factors of 1, which is just 1. So really 1 and 3 divided by 1 just give us plus or minus 1 and 3. So we could plug in plus or minus 1, we could plug in plus or minus 3. Okay, so those are our potential zeros. When you start plugging them in, I found that -1 works, right? So that means that -1 is a 0 and that x plus 1 is a factor. Okay, and then all I need to do is now break down this quotient. So I went ahead and wrote this function in factored form. So we found this factor x plus 1. Our remaining factor is our quotient that we got from synthetic. And then this is one that we can actually factor using the sum product chart, right? And use the shortcut. Yay! So this factors into x plus 3 and x plus 1. When I set it equal to 0 and solve, I'm going to get a -3 and a -1. So my actual zeros are the -1 that I got from synthetic, right? The -3 that I got from factoring the quotient, and then I got -1 again. Now, if you get a repeat 0, that's just talking about, that's just going to be the multiplicity, right? The multiplicity of that factor would be squared, or 2, right? But we don't have to list the -1 twice, okay? Just list it once, all right? Okay, so let's go ahead and look at number 2. Number 2 was just determining which of these given numbers are zeros for this given function. So all we had to do was take each of these numbers, plug them in using synthetic, and see which one gives us a 0 remainder. In this case, only one of them gave us a 0 remainder, which was -5, and all the others did not. So the only answer we should get on number 2 is D. Okay? Everybody okay? That was kind of an easy one, right? And then number 3 was very similar to number 1, but they actually give you your 0, right? We didn't have to find all the potential zeros on this one because they tell you that x equals 3 is a 0. So you start by just putting -3 in your synthetic box. You see that your remainder is 0, obviously, because they told you it was a 0. And then we just need to factor or use quadratic formula to further break down and solve this quotient for the remaining zeros. Okay, this one again is one that was factorable using some product chart, and you could use the shortcut because the leading coefficient is 1. So it factored into x plus 2 times x plus 1. And whenever we solved it, we get -2 and -1. Now notice I only circled -2 and -1. That's because if you get one like this on your homework assignment, they are asking you to find the other values of x, right? So they're assuming you're not going to enter this one because that one was given. So the actual zeros here are -3, -2, and -1. But if one of them is given to you and they're just saying, hey, find the other ones, then you're only going to put in the 2 that you solved for, okay, not the one that was given. Does that make sense? All right, so that is the end of rational zeros of polynomial functions. So you should now be able to complete this assignment in your Alton Newton homework. And if you have any questions, please let me know.